Alright, so in our next section, 8.4, we're factoring binomials. So we are going to be looking at two patterns of factoring binomials. We already looked at the difference of two perfect squares, and now we're doing the sum and the difference of two perfect cubes. So we want to go over finding the cube root of a variable, and finding a cube root of a variable is dividing the exponent by 3. So if I want to find the cube root of x cubed, I'm dividing the exponent by that index 3, which gives us an x. And if I want to find the cube root of x to the 6th power, I'm dividing the 6 by a 3, which gives me an x squared. And remember that we could always check these, right? Our check would be that is x squared raised to the 3rd power really going to give us x to the 6th? And remember, that's the exponent rule called the power rule. So 2 times 3 is equal to 6, and so we see that that is going to work out. Now, here we have the cube root of x to the 12th, so that's division by 3, and so the cube root of x to the 12th would be x to the 4th. And again, you could see if we raise that to the 3rd power, 4 times 3 would equal 12. So that's how you find a cube root of a variable. All right, now with that done, we're looking at the two different patterns here of the sum of two cubes and the difference of two cubes. Now this is pure pattern recognition. So what we want to be able to do is recognize those patterns, that they're binomials and that they're cubes, and then that they're either the sum or the difference. And from there, once we have the cubes, we want to get the roots of those. So it would be helpful for you to know your perfect cubes. 1 through 7 would be great, plus 10. And then what we do is we put them in this pattern. So the cube root of a cubed is a, and the cube root of b cubed is b. We form a binomial with the roots in each case, okay? These are both the same. So we find the binomial with a binomial, the cube of the root, or cube roots of each of those, and then we take the cube root squared for the first term. The middle term is the product of the cube roots, and then always plus the second cube root squared. Now, this kind of looks like a perfect square trinomial, but it's missing the 2 here. It's not. And now, the only thing that makes these two different is the signs that go here and here. So here, whatever this sign is going to go into the middle of the binomial. So with the sum, it goes into the middle of the binomial. And then, whatever that sign is, the opposite is going to go in here. So whatever that is, it's going to be the opposite that goes into the middle of the trinomial. And in the middle of the trinomial for the plus one, we get a minus. And then here, again, the opposite's going to go into the middle. So we had a negative one, and so here we're going to have a positive one. And that's what the patterns look like. So you're going to use those patterns to factor. So let's go ahead and do a couple. So we have binomial, we see a sum, and the variables are the thing that can give us a big clue that this is going to be a cube. And the cube root of 125 is 5, so we have 5x here, and the cube root of 27 is 3. And so now we're going to form our pattern. So we're going to have a binomial, and we're going to have a trinomial. So I'm going to put the root in here, and I'm going to put the root in here. I'm going to take this root, 5x, and I'm going to square it, which means I square the 5, 25, and I square the x, giving me x squared. Then I'm going to multiply these two, 5x times 3. That's going to give me 15x, and I'm going to put that in the middle, and it's always plus, and then I'm going to square this one. So I'm going to get 3 squared, which is 9. And then the last thing that I do is I put in the signs. So whatever this sign is, I put in there, and whatever that sign is, I put in the opposite over here. And that's it. That's how it factors. Okay, let's do it fast again here. 3, b here, a here, binomial, 3b, a, trinomial, 3 squared 9, b squared, product 3ab in the middle, always plus, and then a gets squared. And last two signs, whatever this sign is, goes in the binomial, and then its opposite goes in the middle of the trinomial. And then we have our pattern. Now sometimes it's going to look like you'll want to factor that, but it's almost 100% of the time that it won't factor. So just don't, you can look at it, but don't think it's this perfect square trinomial.